All right, the last part of 6.3 as far as solving or evaluating logarithms or natural logs, before we get into graphing tomorrow, we'll deal with inverses. Okay, inverses are really pretty simple. Anytime you either have a log or an exponent that have the same base. So like if I have log base b of b to a power, okay, so b to the x power. If your base and if the base of your log and the base of your exponent match, then everything is just going to cancel and it's just going to be equal to whatever your power is. Same way goes if you start as an exponent and it's taken to a log power or a power that is a log, and if your bases are the same, everything cancels and it's just equal to whatever your of letter is, or of number. Okay? Everything's going to cancel. But your bases have to be the same. The base of your exponent and the base of your log have to be the same value. So like on example where it's A, it says log of 10 is 10 to the fourth power. Now there's no value, so remember that we can rewrite this as log base 10 of 10 to the fourth. So what is log base 10 of 10 to the fourth? 4. Everything cancels. Now, if you don't have a value, like on B, where it is, like I have log base 3 of 9, can I rewrite 9? Can I go to my list or my table that's over here on the right side on the board? Can I rewrite 9 as with a base of 3? Can I rewrite 9 as a base of 3? What's another way of writing 9? 3 to what power? The second. So instead of having log base 3, so even if they don't start out as being the same, for the most part what's going to happen is that they are going to give you a value. So I can rewrite 9 as 3 squared all to the 2x power. Now, from what we talked about whenever we did power of a power, what is 2 times 2x going to change to? Log base 3 of 3 to the 4x power. 2 times 2 is 4. Or 2 times 2x is 4x. So what is this whole thing going to be equal to? What's going to happen to my log base 3 and the base of 3? They're going to cancel. So what am I left with? 4x. Please don't overcomplicate this. Now, on C it's a little hard to tell, but your log is your exponent. So is the base of my exponent and the base of my log the same value? Yes. So, what's going to happen? What am I left with? 3y. There's my final answer. Now, even on ones like D, where it's e to the natural log of 6, this is why on Tuesday now that I rewrote the natural log. The reason why I rewrite this is because I make it log base e of 6 because it's easier to see and it's easier to tell that what's going to happen here. It's going to cancel and my answer is just going to be what? 6. So the same way, okay, now the last thing. So this was like one of the questions you had at the beginning as far as finding the inverse of a function. You do everything the same way just like we did with an inverse before. So if I had f of x equal to 6 to the x minus 3 power plus 2. If it starts as an exponent or an exponential, it's going to turn into a log. If it starts as a logarithm, and we're finding the inverse, it's going to turn into an exponent. Okay, so there's your kind of hint. So if it starts as an exponent, it's going to turn into a log. If it starts as a log or a natural log, it's going to turn into an exponent. Okay, so if you need to write that down, whenever finding inverse, if it's going to go from exponential, it's going to go from exponential to a logarithm. If it starts as a logarithm or a natural log, it's going to turn into an exponential. They are inverses of one another. That's why we put the two things together. So I'm going to give myself a little bit of room. Well, I think I might be able to fit it. So first thing, whenever I do the inverses, what were the 3 steps that I had to do? What was the first thing I had to do? Change the f of x to what? A y. So I have 6 to the x minus 3 power plus 2. What was my second step whenever we found inverses of functions? Flip the x and the y. So whenever I flip the x and the y, I'm going to have x equals 6 to the y minus 3 plus 2. Again, I am trying to solve for y. So I am trying to get everything, I'm trying to make it into an exponential. So what do I need to move first? Subtract the 2. So I'm going to subtract 2. So I'm going to have x minus 2 equals 6 to the y minus 3 power. Once you get it to be just an exponential on one side, that means I need to move everything else. This is where I'm going to turn it into a logarithm. So before, whenever we changed an exponential to a log or a log to an exponential, what did not change sides? You remember? The base. So my base is here at 6. So I'm going to have log base 6 of x minus 2. That's going to go over. Y minus 3 is going to come to the other side. Now, whenever you do this, the x minus 2, go ahead and put it in a parenthesis, and then have y minus 3 here. It's going to be easier if you put it in a parenthesis, so then whenever, because what are we going to have to do to the left side? Can we leave it as y minus 3 on the left side? No, what are we going to have to do? Add 3. Okay? That 3 doesn't go with the negative 2 or the minus 2. It's its own separate part. And we'll figure that out tomorrow whenever we graph logarithms. So all I'm going to do is I'm going to add 3. And my inverse is just y equals log base 6 of x minus 2 plus 3. So on B, it starts as a log. Now, the first thing that I would do is I would rewrite this more because it's a natural log. I don't have to change. I don't have to change the f of x to a y, so I'm just going to have y equals log base e of x plus 3 minus 9. Okay? The reason why I do this is because it's going to make it easier to figure out what my base of my exponent is going to be. So again, we're finding inverses. So I already have y equals, so now what's my next step? Switch the x and the y. So then I have x equals log base e of y plus 3 minus 9. Now, before I had to get the exponential by itself. Here I need to get the logarithm by itself. So what do I need to move first? The 9. So I'm going to add 9 to both sides. And I'm going to get x plus 9 equals log base e of y plus 3. Now I can change it into an exponential function. So if I'm going to change it into an exponential function, what does not change sides? The base, right? So what's the base? E. Okay. The reason why I write this as log base e is because normally whenever students see a natural log, they don't remember what the base is. Whereas if they write it as log base e, normally it makes it easier for them to understand that it's just going to be e. This goes over to one side. The whole thing comes over. So it's going to be e to the x plus 9 power on the right. And it's going to be y plus 3 on the left. Now, am I finished? Nope. What's the last thing I have to do? Subtract the 3. So I'm going to have y equals e to the x plus 9 power minus 3. The biggest thing with inverses is to, one, take your time and just stick with the same rules that we did before. If you start as an exponential, it's going to either turn into a log or a natural log, depending on what your base is. The only time it'll ever be a natural log is if your base is e. Same way, if you start as a natural log, your exponential will finish as e to a certain power. Everything else, it's just a standard exponential. If it's a base of 6, it's a base of 2, it's a base of 1/2. Okay? That will then just be your base and your exponential. But the only time that it'll ever be e or the natural log is if you have a base of e to start, or if it starts as a natural log, it'll turn into e as your base.